Now I want to introduce the idea of the empirical rule. And this is one nice short way of thinking about what the percentages and the probabilities of a score are within the normal distribution without using a calculator. So we can see underneath this curve here, we have our z-scores, our standard deviation. Again, we see right down, smack down the middle, we see a z-score equal to 0, a standard deviation equal to 0, means equal to 0. And we see plus or minus 1 standard deviation or 1 z-score is going to be about 34% away from the mean. So if we're thinking about how many scores fall within plus or minus 1 standard deviation, we would say that 68% of all scores will fall within plus or minus 1 standard deviation. We see that if we move outside the curve and we look at the scores between plus or minus 2 standard deviations, we see that that makes up 95% of all scores. And if we look at how many scores fall within plus or minus 3 standard deviation, that makes up almost all possible scores. It makes up 99.7% of all scores. So outside of 3 standard deviations, plus or minus 3 standard deviations, we have about 0.3% of all scores that lie outside of 3 standard deviation units away from the mean. So the empirical rule is essentially 68, 95, 99.7, where these three numbers correspond to 1, 2, and 3 standard deviation units away from the mean. Plus or minus 1 standard deviation unit contains 68% of all scores. Plus or minus 2 standard deviation units contains 95% of all scores. And plus or minus 3 standard deviation units contains 99.7% of all scores. So this is a nice shortcut of trying to figure out the probability of percentages of scores without using a calculator. Here's a video. I encourage you to watch this video to see an example problem of how we work through a problem trying to find out the percentage of all scores using the empirical rule and without using a calculator. After you watch this video, move on to some practice problems. Okay, so here are some examples. Assume a normal distribution of MCAT scores with a mean of 32 and a standard deviation of 2.5. So without using a calculator and using the empirical rule, find the approximate percentage of scores that fall below an MCAT score of 24.5, fall above an MCAT score of 34.5, and fall between an MCAT score of 27 and 37. Go ahead and use the empirical rule. Don't use a calculator, and see if you can come up with the approximate percentage of scores that fall below, above, or between these scores. Pause the video to work through it, and unpause it when you've worked through these problems. Okay, so here we go. Let's see how you did. So the first thing is, hopefully you drew out the normal distribution curve. And the first thing you'd want to do is remember that we have standard deviations. And you want to use these standard deviation sections and correspond them with your raw scores. So we know that we have a mean of 32. We have a standard deviation of 2.5. So if we were to plot this, we can put our raw scores, and where would we put our mean? Right down in the middle, which corresponds to a standard deviation of 0. So we'd put our mean right here in the middle. And so now that we have our mean plotted here with our raw score underneath our curve, we can then say 1 standard deviation above the mean is equal to what raw score? Well, we see a standard deviation of 2.5 with a sample mean of 32 is a standard deviation. So 1 standard deviation unit away from the mean would give us this raw score of 34.5. And 1 standard deviation below the mean would give us 29.5. If we did this for standard deviation units plus or minus 2, we'll have 37 and 27. And our raw scores that correspond to 3 standard deviation units above and below the mean are 39.5 and 24.5. So now that we've identified what the raw scores are underneath our curve, we can just use the empirical rule and figure out, okay, so if we wanted to know this percentage of all scores that fell below 24.5, well, we know that 24.5 corresponds to 3 standard deviation units below the mean. And we know that plus and minus 3 standard deviation units contains 99.7% of all scores. So that means if we looked at the entire possible curve, 100 minus 99.7 gives us 0.3%. Well, we know that this 0.3% is going to be in both of our tails. So we divide this by 2 to give us 0.15%. So 0.15% of all scores fall below an MCAT score of 24.5. What about the percentage of scores that fall above 34.5? Well, because we've plotted out our raw scores corresponding to standard deviation units under the normal distribution curve, we see that 34.5 corresponds to 1 standard deviation unit above the mean. And so if that 1 standard deviation unit above the mean, corresponding that with a negative 1 standard deviation, we see that that contains 68% of all scores. And if we just do 100 minus 68%, we have 32%. So since we want to look at scores above 34.5, we see that the remaining 32% makes up 2 end tails. So we just want to know above, so we have to cut that in half to look at this section here. And we know that 16% of all scores fall above 34.5. And looking at the scores that fall between 27 and 37, well, we see 27 and 37 correspond to plus or minus 2 standard deviation units above the mean, correspond to plus or minus 2 standard deviation units, which, using the empirical rule, corresponds to 95% of all scores. So we really didn't even use a calculator at all here to find out the scores that fall below 24.5, that fall above 34.5, and fall between 27 and 37.